The headlights of a car on a foggy night, the blue sky on a clear morning, all portray what is known as the Tyndall Effect. Tyndall Effect is an effect where light is dispersed in many directions when passing through a colloid. In general, longer wavelength of light will pass through the walls, whereas shorter wavelength will be reflected in other directions.
This is because longer wavelengths have low frequency, where the photons do not have enough kinetic energy to be absorbed by the atomic transitions. The intensity is inversely proportional to the wavelength, as you can see in the equation.
Why a cloud not exhibiting Tyndall effect can be created inside a jar? Things you will need: milk, aerosol, jar, hot water, laser, and a bowl of ice.
First we pour some hot water inside a jar, then spray an aerosol into it and immediately cover it with a bowl of ice. At this point, water vapor from the hot water rises and condenses when it comes into contact with the cold air towards the bottom of the bowl of ice. The aerosol acts as a cloud condensation nuclei which provides a surface for water vapor to condense. Once we lift the bowl, we can see the cloud clearly formed. Let's see if the cloud exhibits Tyndall effect. No, it does not. When we point the laser beam into the jar, it forms a straight line and does not scatter. Now let's make sense of the science behind this phenomenon. Since the diameter of the water droplets are smaller than the wavelength of the laser beam passes through unaffected. Let's take a look at another experiment. When we point a laser through water, its pathway cannot be seen. It passes through unaffected. Let's see what happens when we add a tablespoon of milk. This time the laser light does not completely pass through. Instead it forms a conical structure called the Tyndall cone. Why does this happen? The light disperses into a conical structure because the diameter of the milk particles is larger than the wavelength of the laser beam. The milk particles will scatter the light and the path of the light can be seen clearly. There are several applications of the Tyndall effect in the chemical industry, such as the nephelometer, an instrument used for measuring concentration of suspended particulates in a liquid or gas colloid. This is important for measuring air quality, global radiation balance, and many more. Another example is the ultramicroscope, which is used to observe extremely small particles. The ultramicroscope system is based on light scattering and not reflection, and is generally used to observe aerosols and colloids.